Hello again, students. Really short video today. We're going to review graphing. Some of it is slope-intercept form, which we just reviewed yesterday. But we're also going to review graphing with x and y intercepts. So slope-intercept form, that's the one that we are probably the most familiar with. Not just because we just reviewed it yesterday, but also because we used it the most out of all the graphing stuff that we did. So slope-intercept form is y equals mx plus b. The m, you know, that stands for the slope. That's how our line is going to move. Might be going uphill or downhill. Might be really steep or really flat. The y-intercept is where we begin on the y-axis. The ordered pair, a lot of times I just talk about the y-intercept as just a number. But the ordered pair, remember, the x is 0 because I didn't go sideways at all, and then I would find the y number to go into that ordered pair. So when we do this, we're going to graph the y-intercept, and then we use the slope, and we get several more points, at least 2 more points, to try to get a decent line. Standard form, on the other hand, looks like this. And we did some of this, but again, it's been quite a while. So standard form has the stuff with the x and the y together on one side. So it's not like the y is all by itself like we have in slope-intercept form. The c, remember, that just stands for a constant. It's just some number. So we want to be able to find the x and the y intercepts to be able to graph from that. Or we might want to change it into slope-intercept form and graph from that way. What we have here for the x-intercept and the y-intercept, notice where the zeros are. I want to remind you that when we graphed like this originally, we made a tiny table of values with zeros. And then remember, I made a big deal about I love substituting zeros because it makes things easier. Now look at what's going to happen here for the x-intercept. That's that point right there, where the y was equal to 0. I'll find the x number, and that's where it's going to cross the x-axis. And then right here is that one. Because when the x is 0, I'll find the y number, and that's where it crosses the y-axis. So if I have this problem and I want to graph it, finding the x and y intercepts. So again, remember, we're plugging in zeros. I really do like to just make that little table of values. I can see it as ordered pairs, gets me my information, keeps it all organized. If the y is 0, when we did this, I hope that you remember, I would say, so I would put a 0 right here for this y. Well, then that's going to be 2 times 0. And 2 times 0 is just 0. And adding 0 doesn't do anything. So in class, I just use my hand and I cover up that plus 2y part. Right now, I'm just going to say, well, if the y was 0, this is going to be adding 0, and I don't need to do that. So all I really have right now for my equation is just 6x equals 24. Well, 6 times what gives me 24? That's going to be a 4. Now, if I move on and I want to find the y-intercept, that's what happens when the x is 0. So if I put a 0 right here, 6 times 0 is 0. Adding that 0 to the beginning of the equation doesn't do anything. So again, I can kind of ignore that. So I would say 2 times what gives me 24? Well, that's going to be 12. So 4, 0 is right there. And 0, 12, I believe, is at the top. 1, 2, 3, 4. Right there at the top. Once I have my x and y intercepts drawn, you would use a straight edge, line it up, draw your line. This isn't like slope-intercept form where you get a whole bunch of points. In graphing with intercepts, you get 2 points. You get the x-intercept and the y-intercept. So if I graph this then, not a real straight line, but I didn't use a straight edge, sorry. Okay. What if I take that exact same equation and I say, let's change it into slope-intercept form? I want to solve for y. Part of your assignment today, you need to do that. We need to practice that. So we're going to get the y all by itself on one side of the equation. So let me rewrite this. 6x plus 2y equals 24. Remember, I'm trying to get the y by itself. So I have to leave the 2 alone because it's attached to the y. How do I get rid of adding 6x? Well, I would subtract 6x from both sides. And remember, for slope-intercept form, I know technically I could say 24 minus 6x. That's not how I want it to look. I would rather have it look like negative 6x plus 24. And then I'm almost done, but I don't want 2y. I just want the y. I want to get rid of multiplying by 2, which means I'm going to divide by 2. But everybody gets divided by 2. Y equals negative 6 divided by 2 is going to be 3, or 3 over 1 if you want a fraction, x plus 24 divided by 2 is 12. Well, we know the 12 is at the very top of the graph. If my slope is a negative 3, I would go down 1, 2, 3, and over 1. And remember from the last slide, our x-intercept was at 4. That's what I just hit. Okay. So this way I do get a lot of points. And again, for me on the smartboard, it's much easier this way. Not that yeah, that's not really all that straight, I'm sorry. But there's my line. It's the same line, right? Not a real well-graphed line there, but those are the same lines. So I can get the same information. So today, we're going to be doing this worksheet. Says graphing lines practice worksheet. The answer key is in Schoology. There is a learning check in Schoology, but I want to do the first problem from the worksheet together with you right now. So what's going to happen here is I'm going to give you equations in standard form. So we want to find the x and the y-intercept from that. I also want to get slope-intercept form from that and get all of my information in that third column and then finally be able to graph this. So in this first section, I would make this table of values. If the y is equal to 0, remember that means that this y turns into a 0 and adding 0 doesn't do anything, so I can just kind of ignore this. So 2 times something gives me 7. Well, that's not ideal, I know, but it'd be 7 over 2 or 3.5 or 3.5. Then if I would switch it around and say that the x is 0. So 2 times 0 would make this whole thing into a 0, and we don't need to add 0, so it's just that y equals 7. So I can fill in my x and y intercepts. So this is going to be 3.5, and this is, oh, that's kind of smudgy, I'm sorry, and that's 7. If I change that equation into slope-intercept form, I would have I'm going to subtract this 2x from both sides. So I would have negative 2x plus 7. So the slope is going to be a negative 2 or a negative 2 over 1. And my y-intercept is 7. Oh, look at that. These two better match. They're the same information. So when I graph that, 1, 2, 3, 4, 5, 6, 7 is at the very top of this graph. Instead of graphing 3.5, which I could actually get a point right there, it's going to be like right there. Let's graph our negative 2 slope. So down 2 over 1, down 2 over 1. So there's my line. It is going to go through that x-intercept like it should. And there's my line. So that's what we're practicing today. That's what the rest of your worksheet is going to look like, where you are finding x and y intercepts and changing into slope-intercept form, noticing that it gives you the exact same information when we actually get to the graph. When you're done, don't forget about the learning check in Schoology, and let me know if you need any help.